Hi friends, in this video I will explain independence test method. This method is used to determine whether a given set of vectors is linearly dependent or independent. The prerequisites of this lecture are echelon form and reduced row echelon form. Let us first try to understand the meaning of linear dependence and independence of a set. Let S be a set that contains vectors u1, u2, un. Then these vectors are said to be linearly dependent if there exist scalars c1, c2, cn, not all 0, such that c1u1 plus c2u2 plus cnun is equals to 0. Not all 0 here means that all of the scalars cannot be 0 simultaneously. So, if there exist some non-zero scalars c1, c2, cn such that c1u1 plus c2u2 plus cnun is equals to 0, then the set S is linearly dependent. If there does not exist such scalars, then the set S is said to be linearly independent. That means that whenever c1u1 plus c2u2 plus cnun is equal to 0 implies c1 0, c2 0, cn 0. So if all of the scalars come out to be 0, then my set S is said to be linearly independent. Having known the concept of linear dependence and independence, let us move forward to the method that helps determine whether a set is linearly dependent or independent. So let us now discuss how ITM works. So ITM stands for Independence Test Method. So we are given a set S that will contain some vectors u1, u2, un, and I need to find out whether S is linearly dependent or linearly independent. So how do we do that? For this we first construct a matrix A. Now this matrix A is constructed in a way that the columns of these matrices are vectors of S. So u1 will be my first column, u2 will be my second column, and un will be my nth column. After having this matrix A, we find the reduced row echelon form of A. So the second step here is to find the reduced row echelon form of A. Third step is eventually the conclusion. If in the reduced row echelon form of A, every column is a pivot column, then S is linearly independent. So if every column is not a pivot column, then S will be linearly dependent. Now I'll just quickly recapitulate what a pivot column is. So a pivot column is basically a column that contains a pivot, and a pivot is the first non-zero entry of any row. So for ITM, what do? We first construct a matrix A using the set S, where columns of A are vectors of S. Secondly, we find the reduced row echelon form of A. After finding the reduced row echelon form of A, we examine whether every column is a pivot column or not. If every column is a pivot column, then S is linearly independent, else it is linearly dependent. Let us take some examples to see how it works. So now here I have taken this example where I have taken my set S to be 3, 1, minus 1, minus 5, minus 2, 2, 2, 2, minus 1. So I need to find out whether S is linearly dependent or independent. So as I said, we'll first construct our matrix A. So a matrix A is constructed whose columns are vectors of S. So the first vector is 3, 1, minus 1. So that is my first column now. Similarly, second vector minus 5, minus 2, 2 becomes my second column. 2, 2, minus 1 becomes my third column. So this is my first step where I have constructed my matrix A. Now after this first step here, I move on to find the reduced row echelon form of A, for which I'll have to apply series of row operations. So let us just quickly see what do we get. So to find the RREF, I'm interchanging these two rows. So R1 is interchanged to R2. So once I do that, A becomes equivalent to 1 minus 2, 2, 3, minus 5, 2, minus 1, 2, minus 1. After this step, since this is 1 already now, I try to make this 0 and this 0. So for this I apply operations. R2 goes to R2 minus 3 times of R1 and R3 goes to R3 plus R1. After applying these two operations, my matrix A will now be equivalent to, so now it will be 1, minus 2, 2, 0, 1, minus 4, 0, minus 3, 1. So after this step, I move on to my next pivot. So this is my next pivot, next row, first non-zero entry. Now I try to make this 0 and this 0 by applying the operations. R1 goes to R1 plus 2 times of R2. R3 goes to R3 plus 3 times of R2. After this, the matrix now becomes equivalent to 1, 0, 0, 0, 1, 0, minus 6, minus 4, minus 11. Next, we move on to the next pivot, which is this. So we make this 1. So we apply the operation. R3 goes to minus 1 by 11 of R3. And now the matrix becomes equivalent to 1, 0, 0, 0, 1, 0, minus 6, minus 4, 1. After this step here, I make this 0 and this 0. So the operations involved are R2 goes to R2 plus 4 times of R3. R1 goes to R1 plus 6 times of R3. After these operations, now I finally get my RREF, and this is my RREF. So I see that there is a pivot in every column. Since there is a pivot in every column, that means S is linearly independent. I hope it is clear here. If any step is not clear to you, please feel free to comment. Next, we take up another example. Now here I have taken S to be 2, 5, 3, 7, 4, minus 9, minus 8, 3. Again, we construct A. So A is my matrix whose columns are vectors of S. So the first vector is 2, 5. So this is my first column. Then 3, 7, 4, minus 9, minus 8, 3. So this is my matrix A. Now I find the RREF of A as above. So I am straight away writing down the RREF here. So here my RREF is coming out to be 1, 0, 3 by 2, 1, 2, 38, minus 4, minus 46. So from the RREF we can see that only first two columns are pivot columns. So that means now because every column is not a pivot column, so S is linearly dependent. This is how ITM works. I hope it is clear to all of you. For any query, please feel free to comment below. Thank you.